Okay, so I'm going to start off by just speaking about my gear. This is a very popular setup. It's the Celestron Evolution mount. And what I like about this mount is that not only could you attach an 8-inch tube, you can also attach a 6-inch tube to it. What I attach in addition to that is my solar scope and my 80 millimeter refractor. So it's an alt-as mount, so it doesn't track as good as other mounts, but an equatorial mount, but it does a fairly good job if you're imaging for, well, about a minute and a half, maybe 2 minutes, if I'm lucky. I'm also using a Mallancam Skyraider 10C. And what you see here is the Mallancam attached to my solar scope. And attaching the Mallancam to the camera, to the computer is fairly easy. I just attach a USB 3 wire to the camera, and I run it through my sliding glass doors of my balcony and onto the computer, onto the laptop. I turn on the software that came with the camera, and I could then operate the camera controls from the computer. I could enhance the image by minimizing noise. I can increase the detail inherent in a raw image. I could perform live stacking, take snapshots and videos, and a whole lot more. In an effort to combat light pollution, I generally use filters. Typically, I use an ultra high contrast filter. I would also, one of my favorite filters to use is an Octalong L-enhanced filter, which isolates hydrogen alpha, beta, and oxygen 3. So this is an unprocessed image that I took with the camera. And I just like to show you some of the granulation here that is caused by the turbulent convection that's occurring in the convection zone. Little bit of solar activity going on there. Okay, so these are deep sky objects. This is the Flaming Star Nebula, IC 405. And it's classified as both an emission nebula and a reflection nebula in the constellation Orion. An emission nebula involves high energy stars, ultraviolet light, which ionizes gas around it, which in turn emits light of various wavelengths. A reflection nebula involves clouds of dust that reflects the light from the stars in the nearby area. This is a crop image of the Crab Nebula, which is a supernova remnant. And as you've heard before, when a massive star runs out of fuel, a star much larger than our sun, it causes the outward pressure to drop, gravity wins out, the star suddenly collapses. And if you can imagine something 1 million times the mass of the Earth collapsing in 15 seconds, it's quite an event. The collapse happens so quickly that it creates an enormous shock wave that causes the outer part of the star to explode. A second type of supernova can happen in systems where you have two stars orbiting one another, one of them being an Earth-sized white dwarf. And the white dwarf is really what's left of a star about the size of our sun that runs out of fuel. Well, if the white dwarf collides with another one, or if it pulls too much matter from a nearby star, the white dwarf becomes unstable and it explodes. Astronomers believe that about 2 or 3 supernovae occur each century in galaxies such as our Milky Way. However, there are many, many galaxies in our observable universe. This is another example of a supernova remnant in the constellation Gemini. This is the Jellyfish Nebula, and it's approximately 5,000 6,000 light years away. Now I'm going to show you some of my favorite summertime deep sky objects. This is the Lagoon Nebula. And the Lagoon Nebula is an emission nebula. It's an H2 region of ionized hydrogen where star formation is forming within this huge nebula. The Lagoon Nebula is approximately 5,000 light years away. And here is the Swan Nebula. You've seen this several times before. It's in the constellation Sagittarius, and it's approximately 5,000 to 6,000 light years away. This is the Trifid Nebula, Messier 20, in the constellation Sagittarius. And if you could believe it, the radius of the Trifid Nebula is 21 light years. It's approximately 5,200 light years away. The next image that I'm going to be showing you is the Triangulum Galaxy M33. And M33 is the third largest member of our local group, and it's approximately 2.7 million light years away. Well, you all know what this is. This is one of my favorite wintertime deep sky objects. This is the Orion Nebula, approximately 1,300 light years away. And with this particular shot, what I tried to do is to capture the trapezium. And I did that by starting the stack with low exposures and then building them up to higher exposures. And by doing that, I was able not to blow out the core, which typically happens when you image M42. And this is another image of M42. And you also have the Running Man Nebula right about there. Okay, we're just going to move right along here. This is M51. And this is the Whirlpool Galaxy in the constellation Canes Venatici. And as mentioned earlier, it's interacting with another galaxy, Ngc 5194. It's approximately 23 million light years away. One of my favorite deep sky objects. Okay. All right. Okay, I'm trying to get to the next. Oh, here we go. Okay. So this is the Ring Nebula, and this is a planetary nebula approximately 2,300 light years away. And if you look up, if I can just give you a just a close-up of this, you can see the white dwarf right here in the center. This is a planetary nebula, one of my favorites. And this is the Black Eye Nebula in the constellation Coma Berenices, approximately 17 million light years away. Quite beautiful. I imaged this not too long ago, and we can still see it. This is M66 in Leo, part of the Leo trio. And as you could see here, it seems to be missing an arm there. So the thinking is that this galaxy had some company, or it may have run into another one. All right. This is M81, and this galaxy is an Ursa Major, 11.7 light years, 11.7 light years away. No, I think I got that wrong. Let me skip that. The diameter of M81 is 90,000 light years. You can imagine that. And I really like the detail that I was able to get with that one. This is M94. I showed this a while ago at the RASC meeting we had a few days ago. We had yesterday. This is a galaxy in Canes Venatici, 16 million light years away, and I really like the some of the detail that's captured here. I would never be able to do this without filters, by the way. This we're in a light polluted city, but yet it's amazing what we could capture when we use the right filter. Well, this is M101, and as you can see, there are a lot of deep sky objects here within the vicinity of M101. All right. This is M106 in Canes Venatici, 23 million light years away. And we're going to move on to the Barkarian's chain, which I showed before. Just a beautiful stream of galaxies here. Quite nice. And the next object, and you've seen this a few times, this is NGC 891 in Andromeda. This is the California Nebula. It looks like the shape of California. That's why it's called the California Nebula. NGC 1499 in Perseus. It's an emission nebula. This is the Monkey Head Nebula because it looks like a monkey head, I guess. NGC 2174. This is an H2 emission nebula in the constellation Orion. And moving right along here, this is a close-up of the Rosette Nebula in the constellation Monoceros. This is the Eskimo Nebula. It's a planetary nebula in the constellation Gemini. And this nebula is considered a bipolar nebula because there are two poles that you can see there on both sides of the central star. So that would be here. And you can see some really nice detail in this image. This was another image that I stacked very gradually, beginning with very, very short exposures. And as I built up the stack, I was able to increase the exposure and get the periphery of this planetary nebula without blowing out the core. The next one is the Hamburger Galaxy Ngc 3628 in Leo, and it's one of the members of the Leo trio. The next one is the Cocoon Galaxy Ngc 4490 in Canes Venatici. The next one is the Whale Galaxy in Canes Venatici, 30 million light years away, NGC 4631. And you can see another, I think this is called the Pup, I believe. And correct me if I'm wrong. This is the Witch's Broom, which is a supernova remnant. It's part of the Veil Nebula, NGC 6960 in Cygnus. And along with that is NGC 6992, the Veil. This is the Helix Nebula, which is a planetary nebula in the constellation Aquarius, NGC 7293. And this is the Bubble. It's NGC 7635. It's an H2 emission nebula in the constellation Cassiopeia. One of my favorite deep sky objects. And this is a very familiar object here. You have the Flame Nebula here, and you have the Horsehead there, and this is Alnitak, the star Alnitak, and this is in the constellation Orion. And here we have the Medusa Nebula. It's a planetary nebula in the constellation Gemini. And now we have some moonshots. I'll show you a couple of moonshots. We're almost at the end. Now, if you can believe it, this shot I actually took with my iPhone. And what I did was I used my Celestron 8-inch Smith Cassegrain. I attached a Ethos 13 millimeter eyepiece, and I took the iPhone with an adapter, and I connected the phone to the telescope, to the eyepiece rather, and I centered it, and this is what I got. As you can see here, this is the Alpine Mountains, quite nice. This mountain is 5,400 meters high, quite beautiful. And as you can see, Archimedes and Aristotle, and this is the Imbrium Basin here, Sea of Serenity right over there. And I have a couple of other shots of this. I'll get it. There we go. Yeah, this is another one. I just want to show you the resolution. The resolution is quite nice. So folks, you can use your phone to take pictures, to take photos of the moon. You can't really take photos of anything else though. I was under the impression, you know, that I can just take photos of all these deep sky objects. Well, no way. It has to be really bright. And this is the site of Apollo 15, right here. And I believe I am finished. Okay.
Jim, thank you so much for that exhaustive collection of images, and not only impressive, but more so when we know how many of those were done from your light polluted urban setting.
Exactly, just about all of them were done right on my balcony.
We strive for leaving town in dark skies, and you proved that it's not necessary.
I know. Why should I? Well, I shouldn't say that, because you can't beat a dark sky. But when it's cold outside and you're in a light polluted environment, you know, using the right filter and the right equipment really goes pretty far. So I would, you know, encourage other folks to consider city astronomy, if I can call it that.